In this video, I'll show you how to solve the ALEKS problem called Identifying Quantum Mechanics Errors in Electron Configurations. To solve this problem, you're probably going to want to have access to a periodic table. You've got 3 different electron configurations, and ALEKS wants you to fix any errors in those. I do want to let you know that I flipped through a few versions of the problem. I didn't see any instance where the proposed electron configuration was correct. That doesn't mean that that's not a possibility, but if you think that one of these is correct, please look at it carefully because I didn't see that pop up at any point. So before we jump into correcting these electron configurations, I'm going to use this periodic table to mark it up and show you how we can use the periodic table to come up with electron configurations quickly. So first of all, these first 2 columns on the periodic table, these are the parts of the periodic table or the elements on the periodic table that correspond to the s orbital or the s subshell. I do want to remind you that helium, when we're dealing with electron configuration, helium belongs at the top of column 2A. Helium does not belong at the top of column 8A because it only has 2 valence electrons, so it belongs with the other elements that also have 2 valence electrons. This area of the periodic table, leaving helium out, these are the elements that correspond to the filling of the p orbitals. It's called the p block. And this portion of the periodic table, this is where we are filling the d orbitals. We call it the d block. There's also an f block, but I don't think that comes up in any of these particular problems. So also, one last thing, the principal quantum number, so the 1s2 or the 3p4, that corresponds to the row number or the period number on the periodic table. So I'll fill that in. And then there is one slight exception. When we're filling the d block, the principal quantum number is behind by 1. So this is row number 4, and when we're filling the d block, this is going to be principal quantum number 3, this is going to be principal quantum number 4, 5, and 6. So just assuming right off the bat that these electron configurations are incorrect, the first atom that ALEKS wants me to come up with the electron configuration for is the atom that has 18 total electrons. And so this particular periodic table is not doesn't have the atomic numbers on it, but the atom that has 18 total electrons is the one that has 18 protons, has an atomic number of 18, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. That's argon right here. So this is the element that we're writing the electron configuration for our first problem. And the way that we're going to read this element's electron configuration off the periodic table is to just start at helium, paying attention to where we're located, what areas of the electron configuration we're dealing with, and we're just going to work our way from top to bottom and from left to right, starting at helium and work our way to argon. So starting here at helium, we are in the 1s area, and we're going to go through both of those 1s electrons, so that is going to be 1s2. And then once we're done with that, we're going to move to this area, and we're going to go through both of the 2s's as well, so that's going to be 2s2. And then from there, we are going to go to this area, which corresponds to the 2p, and that's 1, 2, 3, 4, 5, 6, 2p6. And then next, we're going to go to the 3s. We're going to do 3s2. And then over here, we're going to be in the 3p's, and that's going to be 1, 2, 3, 4, 5, 6. 3s2, 3p6. So this is the correct electron configuration for helium with 18 electrons. And it looks like there's a couple of things that need to be fixed. You're just going to go in and edit that. Let's do this next element with 13 electrons. I think that's aluminum. If this is 18, 17, 16, 15, 14, 13. Yeah, so our next one we're working on is aluminum. And the electron configuration for aluminum, starting at hydrogen, which is 1s, we got 1s2. We've got 2s2, 2p6, 3s2, 3p1 is where this one's going to stop. So 1s2, 2s2, 2p6, 3s2, 3p1. I realize I'm writing that next to the wrong element. Our last one on here has 7 electrons in it. That's going to be atomic number 7, which I think is nitrogen. 1, 2, 3, 4, 5, 6, 7. Yeah. So our last one that we're going to deal with is nitrogen. right there. And the electron configuration for nitrogen, starting at hydrogen, which is 1s, we have 1s2. Then we move on to the 2s, that's going to be 2s2, 1s2, 2s2. Then from there, we move to the 2p's, 1, 2, 3, 2p3.